This is going to be an introduction video to the explanation of the missile slash rocket that we have built. Now we will be referring to this missile as a rocket throughout the whole videos, because a missile is just a rocket with a warhead, and the warhead is the most, it's like the exploding device. It's what carries a weapon. And for the purpose of this project, for safety purposes, we have not designed any warhead because we are not certified to do so, and neither do we have the expertise to do so. So we will be referring to this missile as a warhead from now on. We will be explaining all the parts of the missile that we have built, and I will be explaining the construction, the mechanical and the chemical properties of what we've built. And I will also be talking about the first trial that we've done, and I will also be showing you the first trial, what happened, what problems that we have diagnosed from the first trial. So first I will be explaining the construction of the rocket, Harush will be explaining the chemical properties of the rocket, and Mustafa will be explaining the mechanical properties and the parts of the rocket. I'm going to be explaining the construction of the rocket and the tripod to it. So first up, we have the rocket itself. Now the rocket has a metal chamber inside of it, which will show separately. So there's a metal chamber that comes up till this height, right? And it's filled with fuel, which is potassium nitrate and sugar, which Mustafa will explain when explaining chemistry. And we have rolled around this metal chamber with some sheet, pretty thick sheet, and with some cardboard we have made fins and a nozzle. What will happen is we will ignite the fuel here with an appropriate igniter, and the rocket should ideally go up.
If you came too front, bro, the audio wouldn't have come properly.
It's okay. You mute, bro.
Second up, we have the tripod. Now the tripod is having a base of a cement block, which was measured and cut in the Helios workshop, and then with 3 plastic pipes cut to dimension and at an appropriate angle to hold the rocket, we have stuck them using appropriate adhesives. Here we have used epoxy, and the rocket stands on the stand with the it's okay, hold it. With the fins, and the fuse will run down here.
I'm Harush and I'm talking about the chemistry part of our EL phase 2. So we all know that a propellant is used to provide thrust in a rocket, and in our case it is the rocket candy we are making. The propellant usually consists of a fuel and an oxidizer. The fuel in our case is the sugar, and oxidizer is KNO3, and it is in the ratio 65% to 35% by weight. If I have to show you the sample, so this is our sample, in which we have 65% of KNO3 and 35% of sugar. It's a homogeneous mixture. And during our first trial, we initially caramelized sugar and then added KNO3. But in the second trial, we mixed both the KNO3 and sugar together, and then put it on the stove for heating. And yeah, you keep the stove on medium flame, and until and unless it becomes homogeneous, you keep stirring it, and then pour it back into the metal pipe which we made. That is the body which contains the propellant.
This is Mustafa, and now I'll be talking about the mechanical design of the rocket. So, first, looking at the chassis of the rocket is made of thick cardboard sheet which is rolled to dimension around the combustion chamber. It's cut to around a height of 2 feet, and a diameter of around 4.5 centimeters. Looking at the combustion chamber was manufactured in the machine shop after we laterally developed the surface on SolidWorks, and it was cut on a sheet metal and mechanically logged. It's filled with the fuel and will be able to handle the impulse provided by burning the fuel. Looking at the nose cone and flaps, the nose cone of the rocket is cut from plain cardboard and rolled into shape. It's in the shape of a right circular cone, and it's attached to the rocket using glue gun. The flaps were also cut out from cardboard and stuck to the body at an angle of 120 degrees to each other using hot glue. Looking at the nozzle of the rocket from which the exhaust comes out is one of the most important parts, as the momentum developed by the rocket in moving upwards completely depends on the velocity of the gases that escape upon combustion, and the nozzle is what determines the velocity of escaping gases. One can say that the nozzle is the most important part of the rocket. So, in the rocket industry, the simplest design of the nozzle is the D level nozzle. It's a tube that is pinched in the middle, making a carefully balanced asymmetric hourglass shape used to accelerate compressible fluid to supersonic speeds. The nozzle increases the specific impulse by playing with the ratio of areas between regions where the gas escapes to generate larger specific impulse. This is in accordance with the Bernoulli's principle in fluid mechanics. This component was also designed on SolidWorks using radial development of surfaces on SolidWorks and manufactured in the machine shop by cutting the sheet metal and mechanically logged. The development of the frustum of the cone is shown here. Now, looking at the tripod, the rocket needs a proper launch pad for it to launch perfectly vertical. For that, the tripod was designed using scrap materials from around the college campus. A fiber slab was cut into dimension and using plastic pipes tilted and at an angle which was stuck to the slab using M seal, and the fins of the rocket rested on these tubes. So this was it about the mechanical design. Thank you.
So talking about what happened in the first trial, we procured the potassium nitrate, sugar, powdered sugar, and the first step was to make the fuel, right? So what happened was we got a stove and we put the sugar in first, and the sugar melted, it caramelized. Then we added the potassium nitrate. Okay. Now this was actually a mistake because now the potassium nitrate sugar mixture somewhat formed granules instead of a uniform lumpy paste, which should have been ideally achieved. And the video is as follows. Now we took one granule of the fuel and we tested it, and these were the results.
Come. Ouch! This is too much, bro.
So the mechanical part, we got a cylinder made in the machine shop, and for the second try we even gotten a nozzle manufactured in the machine shop. Rest all were cardboard, and the tripod was made from a cement fiber block and 3 waste pipes that we found lying in the campus that was supposed to be thrown away. So mostly we've used scrap materials for this. It's not something that we went and manufactured everything for, except for something that needed precise use cases. The first trial of the rocket went like this, 6 minutes long, as follows. My God.
Boys, be careful. Not deeper. Slowly.
Hey, be careful.
Dying now. Getting off.
Candle is dying.
Oof mad.
Hey, truck ಬಂತು ಅಲ್ಲಿ. Vedram, wait. Vedram, wait.
Wait till the truck pass.
Hey, let the truck pass da.
ನನ್ನ ಐಡಿಯಾ ಇಲ್ಲ ನಿಮಗೆ.
ಏನು ನೋಡು.
You can understand Canada. Like I have an idea. Like see, there like little spaces left more till the fuel. Fill it from little dry leaves and keep the smaller candle down. Where is dry leaves? Then it goes. Always now it's like candle. It won't go light up inside.
ಲೀವ್ಸ್ ಹಾಕೋದ ಒಳಗಡೆ.
Dry leaves ಅದರ ಹಾಕಿ.
ಹಾ, ಆಗತ್ತೆ, ವರ್ಕ್ ಆಗುತ್ತೆ.
How are your eyes, Ra?
Vedram.
Hey, face away from it, da. Don't burn your face and all.
Helmet you should have bought. Hey, do that, bro. Put that dry leaves little down. Then it will catch fire easily.
Then run.
Hey, wait, ತಡಿ. ಬೇರೆ ಮಾಡ್ರು.
Hey, do that, bro. I'm saying just put
Some dry leaves you put.
paper. You just
Paper you can put. That's a better option. Hey, paper you put, ah. Hey, wait, Vedram.
Paper we put.
Hey, no. Dying. Wait. Something is igniting.
You come da then.
Hey, come da.
No, that's not safe,
Face
bro.
away from it, Ra.
Hey,
Vedram, just stop it. Wait.
hey, smoke coming. Come on.
Get down. Hey, put some paper, bro. By now it will catch fire. See.
ಬಿಸಿಯಾಗಿರುತ್ತೆ ಒಳಗಡೆ.
ಇಲ್ಲ ಈಗ ಆಫ್ ಆಯ್ತಲ್ಲ. ಏ ತೆಗಿಯೋ ವೇದ್ರಂ ಬೇಡ. ಏ ಟೆಲ್ ಹಿಮ್ ಟು ಸ್ಟಾಪ್, ಬ್ರೋ. Stop.
He knows it better, Ra.
No paper. If you can put like it will catch fire properly. Like.
You want to leave the candle and come.
ಇವನ್ ಹೆಲ್ಮೆಟ್ ತರಬೇಕಿತ್ತು ಇವರು. Run, dude! Hey!
This is so cool! Launch!
Hey, propeller is coming out, but it's not leaving, bro.
Launch, bro!
ಕೂತಿದೆ, ಅಲ್ಲೇ ಕೂತಿದೆ ಅದು.
Hey, why don't you see, bro? Hey, propellant is there, bro. Hey, come far, Ra.
ಅದೊಂದು
Hot, bro. Hot.
ಏ ದ ಥಿಂಗ್ ಇದು ಗೊತ್ತಾಯ್ತು, ಅದು ಹಿಡ್ಕೊಂಡಿದೆ, ಅದು ಅದಕ್ಕೆ ಹಂಗಾಗ್ತಿದೆ ಅದು.
Hey, boss, da, come far. Leave it. He'll exhaust off. He'll get over.
It's metal pipe.
ಅದು ಮೆಟ್ಲು ಸ್ಟ್ಯಾಂಡ್ PVC ತಾನೆ. ಮತ್ತೆ ಮೆಲ್ಟ್ ಆಯ್ತದೆ.
Hey, Vedram.
Don't go.
ಏ ವೇದ್ರಾಮ್, ಡೋಂಟ್ ಡು ಶಿಟ್.
Too much cock is showing, bro.
He'll blast, da. He'll blast.
It needs more force.
More applause is needed.
Why didn't you ask some aerospace seniors, dude?
Proper psych, bro. The orange thing coming out is good, bro. Water! He'll go, bro. He'll go. Leave. Let it go. Yeah. Half burnt body. What you'll do, da?
Launching!
Launching underground.
Go on, bro.
Don't go closer now. Wait, let it burn off. Let it burn off, da. Come far. Come far. Hey, come far, da. Ending lump, it might blast. Hey, good propellant, bro. The way it was.
It's not getting
It
its
was strong
thrust,
enough,
bro.
but it was coming.
ಅದು ಒಂದೇ ಸತಿ ಆಗ್ತಾ ಇಲ್ಲ ಕಂಬಷನ್ ಒಂದೇ ಸತಿ ಆಗ್ತಾ ಇಲ್ಲ ಸ್ಲೋ ಆಗ್ತಾ ಇದೆ
Slow ಆಗ್ತಿದೆ.
ಹಾ.
ಅದಕ್ಕೆ ತಳ್ಳಬೇಕಾನೆ.
ಥ್ರಸ್ಟ್ ಸಿಗ್ತಾ ಇಲ್ಲ ಅದೇ ಇನಫ್ ಒಂದೇ ಸತಿ ಕಂಬಷನ್ ಆಗ್ಬಿಟ್ರೆ ಆಗತ್ತೆ
Bro, did you see the design somewhere? Design part. You only designed it.
ಒಂದೇ ಸತಿ ಕಂಬಷನ್ ಆದ್ರೆ ವರ್ಕ್ ಆಗ್ತಿತ್ತು
Something to get the thrust, bro.
ಫುಲ್ ಮಾಡಿದ್ದಾರೆ ಫುಲ್ ಕೆಳಗಿಂದ ಇದಾಗ್ತಾ ಹೋಗ್ತಿದೆ
ಹಾ.
ಒಂದೇ ಸತಿ ಆಗ್ಬೇಕಂದ್ರೆ ಮಿಡ್ಲ್ ಯಾವ್ದಾರ ಒಂದು ಒಳ್ಳೆ ಕಾಂಬಸ್ಟಿಬಲ್ ಮೆಟೀರಿಯಲ್ ಇರಬೇಕು
ಇರ್ಬೇಕು.
ಒಟ್ಟಿಗೆ ಹಿಂಗಾಗುತ್ತೆ
ಒಟ್ಟಿಗೆ ಹೆಂಗಾಗುತ್ತೆ ಕರೆಕ್ಟು ಎಲ್ಲ ನೀ ಹೇಳ್ತಿದ್ಯಲ್ಲ ಒಟ್ಟಿಗೆ ಒಂದೇ ಸತಿ ಆದ್ರೆ ಹಾರ್ತಿತ್ತು
The problems that have been diagnosed from the first trial are that the rocket was a little too high from the ground. It wasn't able to hit the ground and create a kickback for it to get the thrust for liftoff. Second up was that we don't have a nozzle. Ideally, the rocket exhaust is supposed to come from a smaller area to a larger area, which creates a greater specific impulse that will help with the upthrust. And third one is, as I mentioned before, is that the fuel was granulated instead of a fine paste. As of making the video, we have not done the second trial yet, as we have saved it for the demonstration to the professors. But we have manufactured a nozzle, we have made a tripod that is of lesser height, and we have made a fuel that is still not ideal, but still much better than what it was the last trial. Here's to hoping that it would fly. Thank you so much.